Hi everyone, today's topic periodic table, session 1. Features of periodic table. This is a periodic table, right? There are vertical columns, horizontal rows. Horizontal rows are called periods. Horizontal rows are called periods. And vertical columns are called groups. How many groups are there? 1, 2, 3, 4, 5, 6, 7, 8. Right? 8 groups are there. In between, there are 10. Look here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In some periodic table, when you are checking, you will notice 1 to 18. 18 groups are there. In some periodic table, it's mentioned 8. So if you wrote 8 or 18, both are acceptable. Now, periods. Horizontal rows are called periods. 1, 2, 3, 4, 5, 6, 7. 7 periods are there. In between, there are 14 plus 14. 28 elements are skipped and keep it down. After lanthanum, 14 elements. After actinium, 14 elements skipped and placed down in the periodic table. They are called lanthanides and actinides. Now we are just mentioning about elements are arranged in the increasing order of their atomic number. In the periodic table, modern periodic table, the elements are arranged in the increasing order of their atomic number and they are organized horizontally and vertically. Horizontal arrangement are said to be periods and the vertical columns are known as groups. Vertical columns, groups, and horizontal rows, periods. In the modern periodic table, this part and this part, both can be broadly divided into two categories, metals and non-metals. In between certain elements, you can see here, certain elements in a staircase model. Certain elements are there. They shows both the properties of metals and non-metals. They are said to be metalloids. Elements can be classified as metals and non-metals. There is a class of elements known as metalloids which exhibit both metals and non-metals properties like gallium, indium. Such type of elements shows both the properties. They are said to be metalloids. Now, variations across a period. Period left to right. When you are checking left to right, the metallic character decreases. Lithium, beryllium, boron, carbon, nitrogen, oxygen, metal to non-metal. That character is changing. Metallic character decreases. As we move down the group, the size increases because the number of shells are increases. And look at the case. First group 1, lithium, sodium, potassium, rubidium. As we go down, the size increases, number of shells increases, and their metallic character increases. Francium is a highly radioactive metal. Now, one by one we can discuss. Group 1, alkali metals. The members are lithium, sodium, potassium, rubidium, cesium, and francium. Hydrogen, in the real sense, hydrogen shows certain similarities, resemblance with the group 1 and certain resemblance with the group 7. So, they have one unique identity property. If you mention hydrogen belongs to group 1, in some point of view, we can accept that statement also. But when we are mentioning the group members, you want to consider lithium, sodium, potassium, rubidium, cesium and francium. What are the specialty of these elements? They are very easy to cut with a knife. That means they are soft metals. They possess low melting and boiling point and their densities are very low. And they are highly reactive. Because of their high reactivity, normally they kept under kerosene oil. When you are checking lithium, sodium, potassium, rubidium, cesium and francium, their outermost shell contain only one electron. Outermost shell contain only one electron. That means their valence shell. Outermost shell is known as valence shell, and that valence shell contain only. When you are checking group 1 from top to bottom, their melting point and boiling point decreases while the density increases, because size, number of shells increases, the size increases. Because of the increase in size, their density increases. They are highly reactive metals. They readily react with oxygen gas. Alkali metals react with water to form alkaline substance. That is, alkalis will form. Sodium react with water to form sodium hydroxide. Potassium react with water to form potassium hydroxide. Lithium reacts quickly with the cold water, but potassium react very violently. That is, it's a vigorous reaction. Now, directly we jump to group 7. Group 7 is halogens. That belongs to non-metals. Fluorine, chlorine, bromine, iodine and astatine. These are the members. Halogens, fluorine, chlorine, bromine, iodine and astatine. Fluorine is a gas. Chlorine also gas. Bromine liquid. Iodine and astatine solid. That means gas, liquid, solid. That is their physical state. Elements in group 7 are known as halogens because they are salt formers. Because of the name of salt formers, their group name belongs to halogens. Their outermost shell contains 7 electrons. Normally, group number indicates the number of valence shell electron. We already mentioned group 1, their outermost shell, valence shell contain only 1 electron. They belongs to group 1. Halogens, group 7, their outermost shell contain 7 electrons. That means their outermost shell, valence shell contains 7 electrons. They belongs to group 7. They are diatomic molecule. We already discussed covalent bonding. Shared pair of electrons are there. So halogens are diatomic molecules. Moving down the group, melting point and boiling point increases. Their color intensity increases. Pale yellow, brown, at last it reaches to dark. That is, the color gradually increases. Chlorine is yellowish green gas. Bromine is reddish brown liquid. Iodine is black solid. That means the color will be more intense as we go down the group in halogens. As we go down the group fluorine to astatine, the color will be more dark. Here you can see halogen, fluorine, gaseous state, pale yellow color. Chlorine, gas, green color. Bromine, liquid, reddish brown. Iodine, solid. It's a vaporizing substance, gray color. And astatine is purely black color. Reactivity of halogens. Halogens are highly reactive non-metals as they only need to gain 1 electron for a noble gas electronic configuration. Reactivity of halogens. Halogens are highly reactive non-metals. They need 1 more electron to complete their outermost shell, that is the valence shell. I already mentioned halogens belongs to group 7. Group 7 means what? Outermost shell contain, valence shell contains 7 electrons. Because of 7 electrons, they need 1 more electron to complete their octet. So they are highly reactive non-metals. Larger halogens do not gain electrons as easily as smaller ones because when we increase the size, the effective nuclear charge, the number of shells are increasing, the center nuclear charge, that not much effective to hold or accept the new coming electrons from, that means sharing electrons or coming out electrons from other atom, they are not that much capable to accept. That's why this point mentioned. As a result, larger halogens do not gain electrons as easily as smaller ones. What is the reason? As the atoms increases in size, the force of attraction between the valential electrons and the nucleus is weaker, because the number of shells are increases gradually as we coming from top to bottom, from fluorine, chlorine, bromine, iodine and astatine. The number of shells are increasing, the effective nuclear charge between the center and the valence shell, that is weaker. Because of that weak force of attraction between these two, the electrons coming from other atoms to the halogens, that's not an easy way to accept. That's why they are not easy to gain electrons like the smaller ones like fluorine or chlorine. Chlorine is the most reactive one and iodine is the least reactive one. Halogen shows one particular reaction, that is displacement reaction. Displacement reaction means a highly reactive element displaces a less reactive element from its salt solution. As we mentioned, from top to bottom in halogens, the reactivity increases or decreases? Decreases, right? So highly reactive one on top, fluorine, chlorine, bromine, iodine, that is potassium chloride and bromine. Bromine and chlorine, who is more reactive? Chlorine is more reactive. So chlorine cannot be displaced by bromine. But when you are taking chlorine gas and mix with the potassium bromide, chlorine is highly reactive compared to bromine. So chlorine will displace bromine from potassium bromide. So ultimately you will get potassium chloride and bromine will be displaced. For example, now there are two chairs, okay, two persons are sitting. One another person came to the classroom and he is a little bit powerful compared to those who are sitting in that chair. So the person who is more powerful, he can easily to take out. That is a scenario, situation like survival for the fittest. Who is more powerful, that person is occupied. That is called a displacement reaction. Clear? Highly reactive metal that displaces a less reactive metal from its salt solution. The metal case, the same way, non-metal case also. Halogens undergo displacement reaction. A more reactive halogen displaces a less reactive halogen from its salt. For example, chlorine gas is bubbled into a sodium bromide solution. Bromide ions get displaced by chlorine. Here I mentioned one equation. Chlorine gas react with the sodium bromide aqueous solution, right? So what will happen? Chlorine is more powerful. So chlorine displaces bromine and the product is sodium chloride and bromine gas will be displaced. Next, group 8 noble gases or inert gases. The members are helium, neon, argon, krypton, xenon and radon. Last one here mentioned in this picture, it is 0. Group 8 or group 0 noble gases, inert gases, different names are there. The members are helium, neon, argon, krypton, xenon and radon. They are non-metals. They are colorless gases at room temperature. They are unreactive because their outermost shell is completely occupied. That means they are always in octet number. That is number 8 is there on the outermost shell. And they are monoatomic because they do not want to take part in any reaction because their outermost shell is already completed. Elements in group 8 are known as noble gases. These are inert nonmetals which are found as monatomic gases. Their lack of reactivity is due to their complete shell of valence electron. Hence, they rarely react to form compounds. Under certain conditions, some xenon compounds are noticed. Due to their unreactive nature, noble gases are often used to provide an inert atmosphere. Some applications of noble gases. Helium. Helium is used in weather balloons. Neon, advertising signs. Argon, light bulbs. Krypton, laser. Xenon, photographic flashes. Initial time I mentioned there are certain elements in between metals and non-metals. They act as a bridge between metals to non-metals. These metals are called a transition metals. Metal to non-metals, there is a bridge of metals are there. They also metals. They are called a transition metals. Transition elements are a block of metals found between group 2 and 3 in the periodic table. They have high melting point and high boiling point. They are usually colored compounds. They shows variable oxidation state. They can form ions of different charges. Uses of transition metals. Wide range of applications are there for transition metals. Some of them I mentioned here. Iron is used for steel. Iron and carbon is the composition of steel alloy. Copper is used for electrical wiring and water pipes. Titanium is used for paint. Silver for photographic paper. Manganese, chromium and cobalt additives to steel. Different types of steels are there. Chromium steel, manganese steel, like that. Platinum for industrial and automotive catalyst in a catalytic converter. Iron, manufacture of ammonia, Haber process. Nickel, hydrogenation reactions, that is margarine manufacture. Manganese oxide, decomposition of hydrogen peroxide. Vanadium pentoxide, manufacture of sulfuric acid through contact process. Thank you.